Welcome to digital class. Dear children, today we are going to learn about an interesting concept from the topic polynomials and factorization. We are going to learn about algebraic identities. What are the algebraic identities you are going to learn today? There was a discussion in class 9 between the teacher and the students. The teacher asking the students what are algebraic identities. Many number of students tried to answer, out of which Reshma and Rohit tried to give the answers for the question. So, question was asked by teacher, how can you prove that a into a plus 2 is equal to a square plus 2a? Reshma raised her hand and said, I substitute the value of a as 1 in it. When I substitute a is equal to 1 on the left hand side, the left hand side is 1 into 1 plus 2. So, 1 into 1 plus 2 is 3. So, it is 1 into 3, 1 into 3 is 3. When you substitute the same value of a is equal to 1 on the right hand side, the RHS is a square plus a is 1. So, 1 square plus 2 into 1. So, 1 square is 1 and 2 into 1 is 2. So, 1 plus 2 is 3. So, you got the left hand side and right hand side same for a is equal to 1. There was one more student Rohit, he also tried to answer the question here. So, we can also take the value of a as 3 and prove the result. So, when you take the a is equal to 3 on the left hand side, so you get a into a plus 2 as 3 into 3 plus 2. So, 3 plus 2 is 5. So, 3 into 5 is 15. When you put the value of a is equal to 3 on the right hand side, you get a square plus 2a as 3 square plus 2 into 3. So, 3 square is 9, 2 into 3 is 6. So, 9 plus 6 is 15. So, you got left hand side as 15 and right hand side as 15. So, therefore, he concluded that LHS is equal to RHS for a is equal to 3 also. Good children, is it true for n is equal to 1 and n is equal to 3 only? Both the students said the equation is true for any value of a. Today, we are going to learn about the concept of algebraic identity. And what is an algebraic identity? An equation is called algebraic identity if it is satisfied by any value that replaces its variables. So, the learning objectives of today's class is the students will be able to prove algebraic identities and verify them geometrically. Students will be able to use suitable algebraic identity in numerical problems. Today, we are going to learn about the algebraic identities. We got the first of the identity, x plus y whole square is equal to x square plus 2xy plus y square. So, to prove this, we start with the left hand side, x plus y whole square you can write as x plus y into x plus y. So, how is it you expand this? So, you take the first of the term x multiply with x plus y, second of the term y multiply with x plus y. So, you can write x plus y whole square as x into x plus y into x plus y. So, if at all you multiply x and x into x is x square, x into y is xy, y into x is yx and y into y is y square. We observe that in algebra xy is same as yx. So, therefore, you can write this as x square plus xy plus y square. So, yx is replaced with xy plus y whole square as x square plus 2xy plus y square. So, how is it you prove this geometrically here? We take up square of side x plus y. So, you see this is what is x plus y and here also you got x plus y. So, now what you do is you take up a point on any one side and from this edge you call it as distance x and remaining part is going to be y, because the total length is x plus y. So, it is covered by x and y. Likewise, do the same thing in for all the other sides also. You got x and y, you got the x and y and finally, you got the x and y. So, what you got is 4 points on each of the sides. Now, what you can do is you can join these points with a line. So, you got the first line and here got a second line. So, what you are able to observe here is the entire square has been divided into 4 parts. The first part you see is having sides as x and x is a square. The second part is again rectangle here whose sides are given as y and x, and third part is again a rectangle with sides as y and x, and the fourth part is a square whose sides are y and y. So, you can say that the entire area is covered by these 4 sub regions. So, we can say the area of the entire region is equal to area of all these sub regions together. So, when you take the first one, it is the first region, the second region, likewise the third region and the fourth region. So, the area of this square is equal to sum of the areas of these squares. So, what is the area of this square? To find the area of this square, now here this length is x plus y and here this side is also x plus y. So, you can say that the area of the entire square is nothing but x plus y into x plus y, which is nothing but x plus y whole square. Likewise, you divide into 4 parts. When you take the first part, the area of the first square you got is side is x. So, x into x, area is x square. So, area of the first region is x square. Now, second region you will take is a rectangle here. So, area of this part is going to be length into breadth. So, it is y into x. So, area of second part is y into x or yx. The third part area is x into y or y into x. So, area of third part is y into x or yx, and area of the fourth part which is again a square is nothing but y into y, which is nothing but y square. So, you can say that the area of the earlier region is equal to sum of the areas of all these. So, it is equal to sum of these values. So, we can say area of the square is nothing but x plus y whole square is nothing but sum of the areas of the regions 1, 2, 3 and 4. So, the first region area is x square, second region area is yx, third region area is yx, fourth region area is y square. So, we can say that because xy is same as yx, you can replace yx with xy, you get x square plus xy plus xy plus y square. So, xy plus xy is 2xy. So, it is nothing but x square plus 2xy plus y square. So, you can say x plus y whole square is equivalent to x square plus 2xy plus y square geometrically also. So, let us take an example of applying this formula. So, when you take you want to expand 2x plus 3y whole square. So, here the value of x when you compare with the standard result, the value of x is 2x and the value of y is 3y. So, in place of x you can put 2x, in place of y you can put 3y. So, it is 2x plus 3y whole square is equal to 2x whole square plus 2 into 2x into 3y plus 3y whole square. So, you can write this as 2x whole square is 4x square, 2 into 2 into 3 is 12. So, 12 xy and 3 square is 9. So, it is 9y square. So, we go for second identity, x minus y whole square is x square minus 2xy plus y square. So, here we start with the left hand side x minus y whole square, you can write as x minus y into x minus y, we can separate this as x into x minus y minus y into x minus y. So, further if you take this, you can multiply x and x, x into x is x square, x into y is xy, minus y into x is yx and minus y into minus y is plus y square. So, it is x square minus xy minus yx plus y square. Because xy is same as yx, we can rewrite this as x square minus xy, yx is replaced with xy plus y square. So, therefore, you can write this as x minus y whole square is equal to x square, there are 2 xy, so minus 2 xy plus y square. So, x minus y whole square is x into x minus y minus y into x minus y. So, you can write this as x into x, x square minus x into y, xy minus y into x is minus yx and minus into minus is plus y square. So, because xy is same as yx, you can write this as x square minus xy minus xy plus y square. So, xy is repeated, so you can write as 2xy. So, x minus y whole square is same as x square minus 2xy plus y square. Geometrically, we want to prove the result, we take a square whose side is x. On one of the side and call the distance as y, remaining part is x minus y. So, total distance is going to be x. Likewise, do the same for other sides also, y and x minus y and y and x minus y for all the 4 sides. Now, we got 4 dots, these dots let us try to join with tail here, we get the entire square divided into 4 parts. So, we can say this is what is the first part, second part, third part and fourth part. So, the first part is a square, second part is a rectangle, third part is a rectangle and fourth part is a square. So, when you take the area of the entire square, side is x, area of square is x into x, which is nothing but x square. When you take the 4 parts, the first part you got as x minus y, the area of this square is going to be x minus y whole square. The area of the second part is going to be y into x minus y, the area of the third part is y into x minus y and the area of the fourth part or fourth region is y into y or y square. Now, what you are observing is you got the areas of the 4 regions. Now, I want to find out x minus y whole square. For that I try to remove these 3 parts. So, when you remove these 3 parts you can get only the first part, the area of this part is x minus y whole square. So, we can say that area of the region 1 is nothing but the area of the entire square minus remove these parts. Area of region 2 is y into x minus y, area of region 3 is y into x minus y, area of region 4 is y square. So, area of the region 1 is nothing but area of the entire square minus area of regions 2, 3 and 4. So, we try to write this algebraically. So, it is x minus y whole square is nothing but x square minus sum of the areas of region 2, region 3 and region 4. So, when you multiply this y and x, what you get is y x and minus y is minus y square, y into x is y x, minus y plus y into minus y is minus y square and y square. You see that there is a minus y square and plus y square, you can cancel off. So, what you got is x square minus y x repeated. So, you can write as 2 y x, because x y is same as y x, you can write this as x square minus 2 x y plus y square. Let us try to take a problem here. So, we got 196 whole square. Using the identity, you are going to find the value of 196 whole square without actually multiplying them. So, 196 you can write as 200 minus 4. So, 196 whole square is 200 minus 4 whole square. So, the first one you take it as x, second one you take it as y. So, x is equal to 200 and y is equal to 4. So, you can use the formula x minus y whole square is x square minus 2 x y plus y square, x value is 200 and y value is 4. So, we can write as 200 square minus 2 into 200 into 4 plus 4 square. So, 200 square you can simply find 2 square is 4, there are 2 zeros, you can write it as 40000. So, 40,000 minus 2 into 4 is 8, 8 to the 16, 1600 plus 16. So, 40,000 minus 1600 plus 16 is nothing but 38,416, right. So, this way you can actually find the value of 196 whole square without actually going for squaring the number. Let us go into the third identity, x plus y into x minus y is x square minus y square. We start with the left hand side, x plus y into x minus y. You can separate this as x into x minus y, x into x minus y plus y into x minus y. So, you can write this as x into x, x square minus x into y, x y, y into x, y x minus y square. Since y x is same as x y, you can cancel off these two. What is that you left out with is x square minus y square. So, hence x plus y into x minus y is same as x square minus y square. So, to prove it geometrically, we again take a square of side x. We divide into 4 parts, 4 regions. The first region is a square, second region is a rectangle, third region is a rectangle and fourth region is again a square. So, when you take the first part, the length is x minus y, the remaining part is y. Likewise, same here x minus y and y, x minus y, here y and y. So, you can find area of this region, area of this region, area of third region, area of fourth region. What you want is you want to find out x square minus y square. So, for that you take up the entire square minus remove this part whose area is y square. So, when you remove this part, the remaining region is nothing but x square minus y square. So, we got the area of the remaining region as x square minus y square. We can write this part into two regions. The first region you got it as a rectangle and second is again a rectangle. So, when you take the area of this rectangle here, so you got one of the dimension as x minus y and second dimension as x. So, you want to find the area of this part, it is x into x minus y. You want to find the area of this part, it is y into x minus y. So, we can write this as x into x minus y plus x minus y into y. So, the area x square minus y square is nothing but x into x minus y plus x minus y into y. So, you find that x minus y is common in both. So, you take it common. So, you get x minus y into x plus y. So, you can write x square minus y square is equivalent to x minus y into x plus y. So, let us go for the next identity. It is x plus a into x plus b, nothing but x square plus a plus b of x plus a b. So, to prove the result, we start with the left hand side, x plus a into x plus b. You can write this as x into x plus b, a into x plus b. So, x into x plus b plus a into x plus b. So, when you multiply x and x, you are going to get x square, x into b is bx, a into x is ax and a into b is ab. So, you got bx, ax and ab. So, in these two terms you got x common and you can write this as ax plus bx, or you can simply take it as x square plus a plus b of x plus ab. So, you can write x plus a into x plus b as x square plus a plus b of x plus ab. So, let us go for the next identity. X plus y plus z whole square is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. To prove this result, we take up the first two terms x plus y as t. So, we can write this x plus y plus z in place of x plus y, you can take it as t. So, t plus z whole square. So, it is of the form here it is t plus z whole square. So, it is t square plus 2tz plus z square. Now, what is t here? It is t is nothing but x plus y. So, it is x plus y whole square plus 2 into x plus y into z plus z square. So, when you expand this x plus y whole square, so it is x square plus 2xy plus y square. Now, multiply 2xz. So, 2 is 2xz and 2yz plus last term z square as it is. So, when you rearrange all these terms, the first term x square, second term y square, third term z square, remaining terms, you get it as x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Let us take a simple exercise, 5x minus y plus z whole square. You want to expand this using the formula x plus y plus z whole square. So, for this you can take the expansion of x plus y plus z whole square, compare these two, they are same. So, here the problem is 5x minus y plus z. So, use this 5x minus y plus z whole square, the y you can write as plus minus. So, minus y is written as plus into minus. So, plus into minus is minus. So, just compare, this is what is x, this is what is y and this is what is z. So, x is 5x, y is minus y and z is z only here. So, when you use the result, it is going to be 5x whole square plus minus y whole square plus z square plus 2xy. So, x is 5x, y is minus y. So, 2 into 5x into minus y, 2 into minus y into z plus 2 into z into x value is 5x. So, 5x whole square is 25x square minus y whole square is y square, z square is as it is, 2 into 5 into minus is minus 10 here, 2 into minus y into z is minus 2, you get 2 into z into 5 into x, you can get as 10 zx. So, you get as 25x square plus y square plus z square minus 10xy minus 2yz plus 10zx. We go for the next identity, x plus y whole cube is x cube plus y cube plus 3xy into x plus y. So, x plus y whole cube we can write as x plus y into x plus y whole square. You know the expansion of this, it is x square plus 2xy plus y square. Now, we can separate this, you can write as x into x square plus 2xy plus y square, y into x square plus 2xy plus y square. Now, you can multiply the x into x square as x cube, x into 2xy as 2x square y, x into y square as xy square. Likewise, y into x square, y into 2xy is 2xy square and y into y square is y cube. So, you get x cube plus 2x square y plus xy square plus yx square plus 2xy square plus y cube. Now, because yx square is same as x square y, you can add this to 2x square y, you are going to get 3x square y. And likewise, xy square and 2xy square is 3xy square. So, you can write as x cube plus 3x square y plus 3xy square plus y cube. Now, you can also take like this, you can rearrange this term, write the y cube second term. Now, what is that you observe in common these two here? You got 3x common and also y common. So, when you take 3xy common, you get it as x is left out and y is left out. So, you got x plus y whole cube as x cube plus y cube plus 3xy into x plus y. So, we go for the next identity, identity 6, x minus y whole cube is x cube minus y cube minus 3xy into x minus y. Now, the change you observe in the earlier identity and this identity here, you got a plus and here it is minus. So, you can replace the y with minus y here. In the expansion, x plus y whole cube is equal to x cube plus y cube plus 3xy into x plus y. So, when you put y is equal to minus y here, what happens is you got x minus y whole cube. Here you get x cube minus y whole cube is nothing but minus y into minus y into minus y or simply minus y cube, and you get 3x minus y. So, you can write minus 3xy and x in place of y minus y. So, it is x minus y. So, you get x minus y whole cube is x cube minus y cube minus 3xy into x minus y. When you multiply these two terms, you get minus 3x square y. When you multiply this term with the last term here, you get plus 3xy square. So, you can write the x cube minus 3x square y and 3xy square and finally minus y cube. So, let us take an example on 2a plus 3b whole cube. X plus y whole cube, when you compare with the x plus y whole cube. So, it is nothing but x cube plus y cube plus 3xy into x plus y. So, here the value of x is 2a and the value of y is 3b. So, x is 2a and y is 3b. So, you can write as 2a plus 3b whole cube is nothing but x is 2a. So, 2a whole cube plus y is 3b. So, 3b whole cube plus 3 into x is 2a, y is 3b into 2a plus 3b. So, now you got 2a whole cube. 2a whole cube you can write it as 8a cube. You can write y cube, y is 3b. So, 3b whole cube you can write as 3 cube into cube b cube. So, 3 cube is 27, 27b cube. Then you got 3xy. So, 3 into 3b, when you multiply 3 into 2, 6, 6 3 is 18. So, you get 18ab and you get x plus y as 2a plus 3b as it is. So, you got 8a cube plus 27b cube plus 8ab into 2a plus 3b. So, again you can multiply these two terms. 18 into 2 is 36, a into a is a square b. Likewise, 18 into 3 is 54, a b square you get. So, you get right as 8a cube plus 27b cube plus 36 a square b plus 54 a b square. When you rearrange this, you can write the first term 8a cube as it is, second term you can write as 36 a square b, third term you can write as 54 a b square and finally 27 b cube. So, let us take an example of finding the value of 99 whole cube using the identity. So, this 99 you can write as 100 minus 1. So, you just compare with the standard result. So, it is of the form x minus y whole cube. So, x minus y whole cube is nothing but x cube minus y cube minus 3xy into x minus y. So, here children, what is the value of x and what is the value of y? You can compare here. The value of x should be 100, the value of y should be equal to 1. So, you can use the formula here as 100 cube minus 1 cube minus 3 into 100 into 1 into 100 minus 1. Now, 100 cube is 100 into 100 into 100. So, you can write it as 1 cube is 1 followed by 6 zeros minus 1 cube 1. So, 3 into 100 is 300, 100 minus 1 is 99. So, 300 into 99. So, 1 followed by 6 zeros minus 1 minus 300 into 99. So, when you multiply these numbers, you are going to get 29700. So, when you simplify this, it is going to be 970299. We are going to go for the next identity, identity number 8. So, x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. It is equivalent to x cube plus y cube plus z cube minus 3xyz. When you multiply all the terms and cancel off the common terms, you are going to get the result x cube plus y cube plus z cube minus 3xyz. Now, if you find that this x plus y plus z as 0, what is going to happen? This term is going to be 0. If this term is going to be 0, 0 into something is 0. So, if x plus y plus z is 0, then the first term here is 0. So, 0 into the entire term is going to be 0. So, 0 into anything is always 0. So, we get x cube plus y cube plus z cube minus 3xyz as 0. We get x cube plus y cube plus z cube minus 3xyz is 0. So, bring this minus 3xyz on the other side, result x cube plus y cube plus z cube is equal to 3xyz. So, if you got x plus y plus z is equal to 0, then x cube plus y cube plus z cube is equal to 3xyz. So, let us take an example without actually calculating the cubes. Find the value of 28 cube plus minus 15 whole cube plus minus 13 whole cube. We are going to find the value of this without actually finding 28 cube, minus 15 cube and minus 13 cube. So, let us see here, you take the first one as x, second one as y and third one as z. So, x is equal to 28, y is equal to minus 15 and z is equal to minus 13. Now, just add up all these three values. So, x plus y plus z, what are you going to get? So, 28 minus 15 minus 13, when you add up, you are going to get 0. So, 28 plus minus 15 plus minus 13 is nothing but 28 minus 15 minus 13. So, 28 minus 15 minus 13 is minus 28. So, 28 minus 28 is 0. So, x plus y plus z is 0. So, once you got x plus y plus z is equal to 0, then you got a result x cube plus y cube plus z cube is nothing but 3xyz. So, you got the x cube as 28 cube, y cube as minus 15 cube and z cube as minus 13 cube. So, you can write this as equal to, so it is same as 3 into 28 into minus 15 into minus 13. So, when you multiply this because minus into minus is plus, so it is 3 into 28 into 15 into 13. So, it is going to be 16380. We got few more identities, the identity number 9, x cube plus y cube is x plus y into x square minus xy plus y square. Simply multiply these two numbers, you get x cube plus y cube. Likewise, x cube minus y cube is x minus y into x square plus xy plus y square. So, when you multiply these two terms, you are going to get x cube minus y cube. So, we just take a factorization of 27 a cube plus 64 b cube. So, we can write 27 a cube plus 64 b cube as use the result x cube plus y cube as x plus y into x square minus xy plus y square. So, you can have 27 a cube as 3 a whole cube and 64 b cube as 4 b whole cube. So, when you use the result here, it is 3 a plus 4 b into 3 a whole square minus 3 a into 4 b plus 4 b whole square. So, it is nothing but 3 a whole square is 9 a square and 3 into 4 is 12 a b and 4 b square is 16 b square. Children, today I have learned about the different types of algebraic identities and we have verified some of them geometrically also. Thank you.